Sorry, quick correction. I'm actually head of data architecture rather than head of data analytics. I do work very closely with the various analytics functions. The topic for this talk, I'm actually doing a talk at another sort of AI Congress in London in January, and so that came up first, so I chose this topic then. And just to give you a little bit of context, the reason I chose this topic is because I thought it's always fun to talk about new tech, and I considered picking something perhaps that doesn't get a lot of coverage. I thought maybe I'll do something like OpenAI has been resurrecting genetic algorithms recently, and that's very interesting. It has some properties that you don't need backpropagation and all sorts. And I thought that'd be a cool thing to talk about. But then I thought, well, I'm going to go talk to a whole bunch of people who are very enthusiastic about AI, and there's a very high probability that someone in the audience is doing a PhD in this, and they're going to know more about it than me. So I decided, what can I really bring to the table? I've been at a number of companies. I get bored easily, so I've worked at quite a few companies in quite a few industries, and I've been lucky really to be able to be involved in a number of projects that were based in ML in some form. And there's a lot of excitement around this, but I think the truth is there are companies where this is their bread and butter, like companies like Google who define themselves an AI company, and they really do apply AI to all sorts of things in sort of every part of their business. But I think the average experience is still that there's a lot of companies who just kind of trying to figure out where they stand with this stuff, trying to figure out what they're going to do. So I thought, okay, well, I think a lot of people, there's a lot of enthusiasts, probably people in the audience here who are very keen, have perhaps put a lot of personal time into it, but who struggle to kind of make that real in your work environment. So let's just talk a little bit about challenges and strategies to how you can kind of overcome that and start doing stuff with it. Now, having decided to do this topic, I thought, great, that'll be easy. I'll just go and talk about the stuff and my experiences that I've sort of done before. And then I realized that's actually a 2-hour talk. And I've got 30 minutes. So I'm going to rush through some of this. This is a bit of a helicopter view. And I may need to sort of dive deeper, personally with people afterwards if you're interested in some of these subjects. Unfortunately, that's just all the time allows for. But so I'm going to start first at kind of 10,000 foot and say, here's the things we need to think about, because you do need to think about things like motivation. If you're going to succeed in your environment and kind of bringing this into your business or getting people to cooperate with you, building this stuff. But equally, I'm going to go sort of low down and give you very sort of simple examples and some strategies we've applied, some techniques I think along the way, or tactics, just to get people started. But just to start with a sort of high-level thing, something like motivation is very important. Probably most of the people in this room don't need motivation. So this is not about me motivating you to kind of do more AI and machine learning. I think precisely because you're probably the kind of person that is already convinced that this is the right way to go. You probably feel very strongly that businesses that don't do this are going to be left behind, and you probably surround yourself with other people who feel the same. And you can kind of get into an echo chamber and feel like, yeah, well, it's obvious. Everybody must feel that. And I think one of the issues that you're going to face is that there are still a ton of people who don't feel that. Right? There's, I'd say, the issue really is that everybody has this problem that day to day in your development teams, you've got your sort of business as usual backlog, and that's always going to get prioritized because they're changing the red button to a green button. Someone's done some A/B testing, and that gets you 3 more clicks tomorrow, right? And that's kind of just the reality, right? We're faced with the very immediate next thing, and for most businesses, that tends to dominate. And what we're missing really is, in a lot of businesses, this kind of sense of urgency that why do we need to do this now? So that's the thing that I think you're going to face as a challenge, and you need to be able to work on that. And as technologists, I think we don't always get good at kind of enthusing others with the things that really make us enthusiastic. We spend a lot of time thinking about how to do it, and not as much time thinking about how to bring people along. So. So I like to use this kind of fourth industrial revolution analogy, and I'm sure a lot of you have heard this. I think it's actually very useful actually to use memes that already exist in some form. So it doesn't sound like this is just you coming up with your own kind of story. There's a sense of credibility. People go and read about it and they say, yeah, actually a lot of other people are saying these things. But you do need to get good at telling the story and kind of passing the message along and getting people enthused. And so for those who aren't familiar, I'll just whiz through it because we've got limited time. But the basic premise is just that we've had kind of 4 stages of the continuous industrial revolution, really, where we started with steam, and that was transformative in society. And then, electricity came along, and that was transformative. And then we had computing and electronics, and that would really change society. And now we're at this kind of 4th phase, which is, intelligence. And some people broaden that out a bit. They include things like Internet of Things, because there's this general notion that, we've got sensors everywhere. You've got sensors in your pocket, in your car, in your fridge, etc. And so basically our environment is becoming sort of sensory, and along with that you've got this sort of awareness that comes from intelligence. So suddenly you get this notion of a very sort of aware environment, and clearly that's going to have a huge impact. But I say clearly, and that sounds like an awesome story, but it's not clear to everyone, because science fiction comes up with a lot of cool stuff, but it doesn't really seem real to people. It's like, yeah, wouldn't it be awesome if we had teleporters? But we don't. So I think, talking people through this, you have to first answer the question, well, why machine learning? Why is it such a big deal? And I think you have to get good at just saying that in quite a succinct way. I like to just emphasize the fact that this, it is a lot more than this. It's more than just efficiency. But I think sometimes you need to choose, the simple messages first. And there is a very strong message here just around efficiency. If we think about the Industrial Revolution, that steam was basically about the fact you had you had 50 people weaving fabrics, or perhaps had a sort of a manually managed loom. But you had a steam engine came along and it basically did that automatically, and it did it 24/7. It didn't sleep and all sorts. So it was just way more efficient. And we're essentially in the same place with machine learning right now. We have we've gone from basically writing thousands of lines of code to effectively teaching the machine to learn and having it effectively write the code. Sure, it's a dense mathematical representation of something, but that's effectively what you're doing. Instead of writing the code yourself, you're showing the machine some examples, and it's writing its own code. Now that represents orders of magnitude improvement in efficiency. And just to put that into context, you think about how much code we write. I think Google released some numbers recently that they have about 2 billion lines of code. I think that's across their entire code base against all of their products. But that's just one company, and sure, they're a company that produces a lot of code, but amplify that up to all the companies, all your companies, in every country all over the world. And every university student, and all of those things, and all the code that's being written. And I've not verified these numbers, but you can sort of intuitively think that has to be in the region of trillions and trillions of lines of code. And then you think we've only got 7 billion people on the planet, and we've got thousands of lines of code for every man, woman, and child living today. So that sort of indicates the kind of scale of problem we have, because we have to maintain all that stuff, right? So to kind of get further, we need to be much more efficient. And if you think about what machine learning is doing, basically we're going from then, instead of telling machines very specifically what to do, I mean, we've got a little bit better. We used to tell them, how to move stuff around in registers down at the processor level, right? So we have got a little bit better at kind of giving them instructions up here, but we're still basically being very, very explicit with machines, telling them exactly what to do. And with things like machine learning, we're kind of changing the game completely. You're not doing that. You're just giving them examples, and then you're saying, fine, you figure it out, right? And that's huge. That's a massive increase in efficiency. But the next thing you really have to deal with is not just why. Why is this important? But it is important. You can sort of explain that to people, because it can feel like magic. But the next thing you have to be able to explain is then why now? Because it's really that sense of urgency you want. You want people to start doing something today, like tomorrow morning. And so there, I think this is a little bit more about you've got to do your homework, but I'll use examples everybody's familiar with. I think everyone can relate to this sort of idea of recommenders now. It's not always the forefront of everyone's consciousness, but average people these days, all of them go out and use the web, and they're all consuming thousands and thousands of websites, and most people have had this experience where they're quite surprised they get some sort of recommendation or something on Facebook or somewhere else, and they sometimes they're a little bit taken aback about how did this thing know me so well? So I think most people have had this experience that things like recommenders have become sort of eerily good. And you translate that to kind of, that's billions of people having that experience across millions of websites. And imagine we did that in a really dumb way. Imagine we just coded up the rules. Not code up the actual recommendation, but code up just the rules for the recommendation in a fairly dumb way. There's a F male do this, FX do this, right? If we had this really, really complicated rule set, we'd probably have half of the planet writing recommendation rules for the other half of the planet, right? So, the reality is today, it's here. We've got very stark examples, and they're having a massive effect. I mean, people who have been paying attention to US politics of late will know that, there's this whole debate going on about how this sort of stuff has actually changed, the whole political system in the US. And people mention things like self-driving cars. I mean, clearly people are actually driving, cars are driving themselves. You just need to go and watch a few videos. We have self-driving cars. There's regulatory hurdles. There's a small percentage of situations they're still working on. But we've got these awesome applications that are very clearly demonstrating that we can do stuff that we could never do before because it was just too complex to code. So, but the thing that you need to really make it real, and this is the kind of takeaway from this slide, is that put yourself in this position, and this is where you think about the early industrial revolution, right? And you work for the guy that runs a factory that's got, I don't know, a whole bunch of people, 10, 50, 100, doesn't really matter. They're all kind of weaving fabrics. And you know that there's a guy down the road who's just bought a steam loom, and he's got one guy, and he's basically manning the steam loom, and it's producing 3 times as much material, and, at twice the quality, at half the cost, and all the rest. Now, your instinct as a technologist is to go, to go to the factory owner or the guy you work for and say, we got to do this stuff because it's like really important. And he says, why? What is it? And your instinct as a technologist usually is to try and explain the technology. And the reality is that's kind of usually going to baffle them. So I think the best thing to do is just walk him down the road and show him that the guy down the road is producing much more material at half the cost. And so this is where I say you need to arm yourself. You need to look at your industry or related industries. Like, we work in gambling. There's a lot of stuff that's even relevant to us that, in financial industry and that sort of thing. There's tons of this stuff. Any of you who kind of follow, there's mailing lists and all sorts of things, you'll get hundreds of examples. I get a mail pretty much every day from one source that's just kind of spewing out all the awesome things people are doing in ML and AI. And I know this isn't this isn't about learning to use the tech. This is about learning, who are the people that are using the tech to completely disrupt your industry, and start talking about that and get practice to talking about that in a very simple way. Because if you can do that, imagine you walk that guy down to the factory down the road, and he sees that they're producing twice as much material. You don't have to explain the tech to him. The next day, he's going to go out and want to buy one of those things. So first step, pay attention to motivation. Do people know why you're doing this? Do they really understand? And, are you good at explaining why you need to do it? The next thing, I actually probably have to skim through these because I don't think I'll be able to finish this in half an hour, but I just wanted to mention the flip side of that. Once you kind of get people convinced that, yes, okay, this is really important, this can feel, for me, a bit like sort of the mid-90s. I was doing internet stuff in the mid-90s, and there were a lot of people who were kind of dipping their toe in the water, but they just didn't really get that, in 10 years' time, their entire commercial strategy was going to be dominated by this stuff. So the first bit, that kind of motivation is, I still don't think everyone is sort of 100% there, and there's a lot of companies who still, don't quite get it. And so that's the first bit, just get everyone to really get it, that this is urgent, and it's now, and if you don't take action right now, it really is a kind of a threat to your business. But the second reaction to that is then fear, and in the 1800s, there was serious social disruption. I mean, there were riots and all sorts. I like this picture because it describes the feeling of the time. You've got this work or riot, one or the other. And put yourself in people's shoes back then where, they were used to new tools and they were used to working with animals and all sorts of things. But what made it really feel different is suddenly they were in this position where there was always a human using this tool. Suddenly they were in this position where, there was this machine that kind of did it on its own. It was autonomous, right? And that really made people feel like we're not in this loop anymore, and fear is a rational reaction to that. And so now you're starting to get a lot of these, and it's actually appreciative of some of the stats on the other slide because there were similar studies. This was from an independent article that was referring to, I think, a PwC study about the fact that robots and AI are threatening close to a third of UK jobs. This kind of thing is happening, it's starting to work its way into the news. And there's a lot of people who are genuinely really, really scared of this stuff. And so we need to deal with that. I mean, it's very easy to think about this as, but I don't really care about it because I'm in the middle of this. But you do need to deal with it because you will get resistance. I've seen resistance in projects which you only recognize afterwards that it's basically down to the fact that people just don't want you to succeed with this stuff, right? And something that I've learned over years and years of kind of automation, just forget intelligent automation, just automation over kind of a couple of decades, is that usually it's the people that whose jobs you're automating, who you really, really need. Like you need to understand what they do. And so, there's a hard way and there's an easier way to do this. And this picture, I'll explain it in a second. But I think first, just to kind of deal with that fear at a high level, really, the reason this is more similar, I think, to that first industrial revolution than the last is because than the other two is because the other two, they were kind of more of the same. Yes, electronics and all sorts of things made things a little bit faster and the like, but people still felt, so they got used to the fact that the machine's going to do something, but ultimately we have to tell it what to do. Suddenly, this is one of those kind of something significant has changed again. And the thing that's significantly changed is that these machines suddenly have got smart, they're starting to think. And obviously, if you think, well, if something becomes smarter than me, I mean, that's not just threatening my job, that's kind of existential threat, right? So it's rational to feel scared of that. So let's just deal with that for a second. I mean, do you know how to deal with that? If people are kind of, discussing these things, are you kind of fueling the fear? Because I think as a society, we can worry a lot too much. We've got a negative news bias and all sorts of things. So, the case for that sort of thing is that, look at recent developments out of, say, Google, this idea that we're accelerating very quickly and we're kind of breaking down barriers to intelligence that we thought once before we could never be done with machines. So they've done things like recently, I'm sure everybody here is familiar with AlphaGo, so I won't sort of describe it in detail. If you're not, it's basically a computer beat a human at a very hard game. But the more interesting thing was that, to me, was what came just after that, AlphaGo Zero. So AlphaGo, they trained it on examples of humans playing Go. AlphaGo Zero, they basically have a sort of a competitive system. So they have these agents playing themselves, and that very quickly beat the original AlphaGo. And the interesting thing about that, you're talking about a system, it doesn't really need to train itself on human data. It's a system that's taught itself. It's kind of bootstrapped itself. And then it's beat the pants off of everything else. So, you look at that and you think, wow, that's intelligence we should be scared of. You look at things like they did some work recently on relational networks about effectively just, understanding the relationships between things. Things like transfer learning, where they've got things playing several games at the same time, and you're sort of learning, basically applying knowledge you've learned in one game to another game. You look at all of those things and you think, wow, we really are building machines that are doing things that are incredibly smart. And so, if you just stop there, you think, yeah, okay, we're kind of tending towards this general intelligence. The flip side of that argument is that we can't even really agree on what the definition of general intelligence is. We can't agree at the moment whether, and there are arguments about this, about whether consciousness and intelligence are actually intimately linked or not, whether you can kind of decouple those things. So, this is clearly a very big topic, but my point is that we can't really define the end point. So if you don't know what the target state is, and we're talking about these things accelerating, or we're getting to general intelligence very quickly, how do you judge speed when you don't know what the distance is? The reality of this is that until we've built it, or until we're very close to built it, we don't really know what the spec is. So the truth is, I'm glad that there are people looking at this and thinking about the long-term implications of all of this, but we really actually don't know whether we're 10 years away from general intelligence, 10,000 years away from general intelligence, or if there's certain things that we've just got the wrong idea. So given that, I like to base my bring myself back into reality and say what we do know is we have these narrow ARs. And if we do think then about the kind of 1800s analogy, it's very instructive. I understand why people are scared, and you need to recognize that. But equally, go and watch positive statisticians, people like Hans Rosling. There's also people like Steven Pinker. This is a great video. I encourage you to watch it. It's called 200 Countries, 200 Years, 4 minutes. And it is about 4 minutes long. But basically the conclusion is, he said, you take all of these measures of wellness and essentially they've been going up across the board. This is not just rich nations, poor nations. Across all of kind of sort of human society, you've average access to education, average lifespan, average access to medical care, and that sort of thing has actually been increasing consistently for the last 200 years. So the reality of technology, and something that was actually, that quote that I described, that kind of references PwC report, the reality is later, if you kind of read into the details of the report, they make statements like, well, it's actually going to generate a huge number of jobs. They say that despite all the sort of labor-saving technologies over the last decades, certainly in a place like the UK, we've never had a lower unemployment rate. You know, so I think you need to kind of base, that you can kind of look at the future and you can just express your own negative bias, but you could also say, look, you know, if we have an honest look at a lot of the trends suggest the exact opposite, that actually this is just making our world better. Now, this is, you know, I don't know if you've ever sort of heard the saying, they say, what's the difference between a depression and a recession? They say, well, a recession is when someone else loses their job. A depression is when you lose yours. Okay, so you need to make this kind of personal, right? This is all kind of up in the sky stuff, but how is this going to affect you when you're trying to drive this stuff into your organization? Well, you really need to think about the people on the other end of it. Back to the statement that I made, to automate anything, you usually need the cooperation of the people that you're kind of automating away. And the key to that is not to think in terms of automating them away. You are always, with technology, you always kind of have a choice. You can see it as a cost saving, and with efficiency, that's the downside to kind of making this message too simple about efficiency. With efficiency, you always think, well, this is about saving costs. But in fact, if you ask most CEOs, if you just gave them a choice, you say, well, you can either save costs or you can achieve growth. Almost all of them will tend towards achieving growth, right? And so you can almost always frame your endeavors in this context. You can say, I can take this technology and I can apply it to taking people out of the loop, to making things just lower cost. You can usually take the same technology and say, how am I going to apply that so that I increase the value of those people, so that I increase their productivity? And the truth is, if you start thinking like that, you actually design different systems. You start thinking about building interfaces that people can use to improve the impact that they have on the business. You stop thinking just about taking people out of the loop. And when you do that, then what happens is you start presenting these kind of use cases in a way that people can see they're involved. They start to see how this is actually, all of us kind of resist change to some degree, but I think we can overplay the fact that a lot of people resist change. I think most people get excited about change too, as long as they can see their place in it. So if you think in those terms, if you think, actually, instead of me just taking this to automate away somebody's job, and you think, well, how am I going to use this to make people more valuable? You'll start designing those kind of interfaces. People will start cooperating with you, and then as a technologist, you'll actually find it easier to get your projects off the ground. So that's the 10,000 foot. I suspect I'm kind of running over time, so I have to speed through these last two. I wanted to kind of bring it down a level then and say, look, on the ground, let's talk about practical strategies then. You have to be aware of that stuff, because if you're not aware of that stuff, honestly, you're going to meet a lot of resistance. You need to get good at kind of understanding what the impact is of people and what their motivations are and all that sorts of thing. But let's say you've decided, well, I just want to do something about this. You may be a manager, you may have a team of people, and your business may have decided, actually, we need to do this. The next reaction is very often this kind of rabbit in the headlights reaction, which, forgive me if anyone's not familiar with that expression, it's basically, you have a rabbit, you have headlights. Its reaction is usually just to stand there in fear when it should be, get the hell out of the way. And so this is the reaction a lot of us have when it's like, wow, I'm really excited about this. Okay, somebody came to you tomorrow, give me some budget, do something. The first reaction is like, oh, damn, I've never done this before. What am I going to do next? So the message here is, don't be afraid to think small. It's good to think big. It's good to think about all the things you can achieve. But you can stop yourself doing things when you think of this as, I need to build the thing that's going to change my entire company. If you think instead about the things that are right in front of you, and almost every single team, I can promise you, most companies still have, the majority of their processes are dumb. And I'll give you an example of this in my own team. Now, clearly, we're a data architecture team. We're all about big data and all sorts of things. So we're dealing with a lot of teams, and I can talk to you about use cases that are far grander and more exciting. But I'm deliberately not going to talk about those. I'll talk about a really kind of prosaic use case in our team. And we've just moved a whole bunch of stuff to AWS cloud platform. So we spent a lot of the last year kind of not focusing on cost optimization. It's just like, get it done, right? Build it. And so we don't have particularly good forecasting or anything at the moment. So what we do at the moment, if we got a database like Redshift, if it hits like a 70 or 80% threshold on some measure on storage or something else, then everyone stands up and says, okay, what are we going to do about it? And the problem with that is we then go to procurement. We give them about 10 minutes notice. We say, we need to double the size of our cluster tomorrow. Can you negotiate a good deal with AWS? And of course, AWS knows they need it tomorrow, so they've got no negotiating power. So simple problems like that, right? This is just a forecasting problem. My team is responsible for doing this forecasting. We just have a dumb process right now. So, there, again, we've got all the ingredients that'll make a great machine learning problem. We've got tons of data. We got query logs. We've got stats on or basically measures of processing capability, queue depth. We've got all sorts of kind of nonlinear relationships. Sometimes you change one queue and it can help things, but equally they're still all competing for I/O, and you can have like really weird effects. So there's lots of really interesting stuff in there. We've got tons of data. We've got all sorts of kind of nonlinear relationships, and we can definitely use machine learning in that space. Day one, though, I don't actually want to go to my boss or his boss and make a case for a huge budget to do this stuff. I just want to get along and do it. So day one, what do? We start collecting the stats. We put it in a database. We do some very basic things with things like, let's just do regression on some of the stats. Let's just take out seasonality. Let's do all the stuff that is kind of really vanilla forecasting. Let's automate it. Let's add in a little bit of lead time. I know what lead time I need to give my procurement team. So just add that in and set it up as an alert and just tell us as soon as one of these things, tell us like 3 months in advance of it becoming a problem so we can do something about it. Now that's really simple, right? This is like, it's still intelligent. It's relative to what we were. It's much more intelligent, and it's a form of automation. But having done that, then the next step becomes, okay, well now let's start throwing extreme gradient boosting at some of this. Let's maybe build a neural net or something. Just see what other algorithms give us better results. And there's actually very complicated problems we can look at in that space. We can do much more interesting things. But the point is, if we start there, if you started like, I just want to kind of solve the world, you just don't start, is the problem. So you can just take any process that's in front of you, and every single team has these, and you can say, how can I make that process a little bit smarter? And then you just do something, do the next thing, and then you build in intelligence, and you layer in intelligence. And just to give you a sense of how that can build to really exciting things, I'll give you one more example where my previous company, I worked for a national newspaper. And I didn't go work there because I thought they were the world's best tech company. I'd worked with some of the world's largest banks, some of the world's largest telcos, a bunch of startups. I'd done more exciting kind of technical companies, but I actually just got sick of traveling after 15 years, and I thought, okay, this company is definitely based in the UK, 25 minutes from my house. I'm going to go there. So I went there for 2 years. They still had interesting data. They had a couple of million customers. They had lots of clickstream data and advertising data and the like. But basically, so we started just from the ground up. When I got there, they had a bunch of data scientists. They did what a lot of companies did. They said, hire some data scientists, do some science. And of course, mainly what they did is did reports, and they were very unhappy. So we just built that up from the ground up. We said, okay, next thing, we just need to get you access to data. So we used the cloud. I would encourage you to use the cloud. We used the cloud to kind of get started. We just got some key data sources onto something that they could iterate over really quickly. Next thing is we automated some of their R scripts and got those up and running really quickly. And once we got to the point where the business was basically churning out more of this analytics, then we said, fine, let's build classification pipelines that would involve NLP type stuff, because we're producing a lot of news that involved a lot of I think I'm out of time, actually, but just give me 2 or 3 more minutes. But, that involved a lot of image classification and the like. But it really did start by solving the basic problem, just starting with get big data into a big database. And then, make it quick to kind of spin things up and down, make it easy to deploy things like R scripts. And then we started doing much more sort of distributed processing and Spark and TensorFlow and all the rest. And we kind of gradually built up. And eventually what we ended up with, which I meant to tell a slightly longer story, but I'm out of time, is what we did end up with. We ended up with a multi-mode recommender system, which involved us basically, you have different recommenders for different types of people who've just hit the site and you know nothing about them, and you've got somebody who know everything about them. We started blending it with things like, it's not just about engagement, it's about what do we get back from it? So we started blending it with, we get money from advertising, from e-commerce, from all sorts of things. Are we optimizing that? And we ended up with a fairly advanced system in the end. But the key message there was that we didn't start by pitching that. We started by just solving the next problem. So I think I'm going to have to just skip over some of these, but the key message here was my message to business people is the build, not buy, very important. I think you should try and buy things sometimes, but at the same time, I see people be very kind of casual about outsourcing things like customer analytics, and I'd say, well, that's kind of your core brain. That's your business, right? You should build some things. Clearly, though, further down the stack, there's a lot of really, really interesting. There's a lot of services and things these days that I think the wrong thing to do as a technologist is to just think I want to build everything from the ground up. You wouldn't do that if you were writing code. You would use libraries, you would use modules. If you spent all your time basically writing everything from the ground up, you'd never produce anything that people really appreciate. So I think you need to kind of curtail your instincts to do that. You need to go out and see. If you want NLP type stuff, I've done some of this myself. Right now, I would turn to kind of the Google ARs and the IBM Watsons and that, because their services are cheap as chips. Build on top of that. Don't build it again. Okay, I think I'm out of time, but the last slide was actually about architecture. I'll just make one last comment. It's just about the fact that I do believe you need a plan. You need a plan to how all this stuff comes together. You want to build an awesome business. You want to build a business that uses all of these I think narrow ARs and gradually weaves them together so the business as a whole becomes something that approximates generalized intelligence. You need to plan for that. You need to have a way that people can deploy things and discover things so that everybody's not building stuff over and over again. So there is good architecture to be done here, but this is probably a talk all on its own. My main message is just don't start there. Don't start big, because you'll never get started. That's me.
Thank you very much. And you got the 5 minutes extra because I misquoted your title, so you had some benefit, so we're even now. Thank you very much, Robin. Highly appreciate it.